Good morning, this is Dr. Turner for Integrated Math 3. Today we are going to be focusing on 1.3, which is surface area of solids. It should be a review topic for most of you, and we've covered it before in class, but if not, it's here, and the formulas are all on your formula sheet that's available in class. While you don't necessarily need to know the formulas, just a second, we'll kind of go over what I'm talking about here, okay? So the first surface area formula here, we have 4 pi r squared. That is for the surface area of a sphere. We have surface area of a cone. On your formula sheet, it's read as pi r squared plus pi r s, where s is given as your slant height. If the slant height wasn't given to you in a problem, then you would need to write it as pi r squared plus pi r times the square root of h squared plus r squared, using your Pythagorean theorem because that's a right triangle there. Your next one is the volume of a surface area of a cylinder. So you have 2 pi rh plus 2 pi r squared. That's calculating separately the area of the bottom and top, and then the area around the outside. You have the area of a rectangular prism, which is calculated as 2 times length times width plus length times height plus width times height. And then last, you have the area of a a pyramid. Usually if we're looking at the area of a pyramid, it's going to be that of a square pyramid, which means that the base is going to be a square. Doesn't have to be, and we'll talk about those different types of shapes here in a second. So if we have a square base, something like that. Again, assuming that this is a square base, I apologize for the crudity of my drawings. If we're looking at a square base, then that area formula is going to be where S is the side length of the base, and then we have our actual height, and we have the slant height again. That surface area formula is going to be side length squared plus 2LS. These are a lot to remember, and they can kind of be a little bit confusing if you're looking at this. So there is a way for us to calculate these without having to remember all these formulas, and that falls back to our previous section, 1.1, when we were talking about the net of all of these shapes. So for instance, if I look at the cone, me personally, I may not commit this to memory because I know that if I take apart this shape, I'm going to end up with a circle on the top and bottom, and then around the outside, the wrapper, if you will, I end up with a rectangle. So all this surface area formula is doing really is finding the area of those 3 two-dimensional shapes and adding them together. Similarly, if I'm looking at the surface area for a rectangular prism down here, right, I have 2 length times width, for instance. Well, that is calculating the surface area of the bottom of the rectangle and the top of the rectangle because those rectangles are the same. And then when I go to do length, that's calculating the sides, the left and right. And then if I'm doing width times height, that is calculating the front and the back. So the back here and then the front here, okay? So if I was doing this, I personally would be looking at the area of each of the rectangles and then adding them together, but both of you will get to the same answer. Similarly here on my pyramid, if I unfold this, on the bottom, obviously I have a square, which we should know the area formula by now. And then if I look at the area of the sides of the pyramid, I'm going to end up with a triangle on each side, okay? So these are the area formulas that you need, surface area formulas that you need to know. If you forgot your area of two-dimensional shapes, those areas are also available on that same sheet. So that's available for you as well. What we're going to do right now is look at what your answers should look like. And so this is going to depend on what your teacher is asking you to do. So for me, let's say I was asking you to calculate the surface area of a sphere, for instance. That can differ depending on what the instructions say. So give me here just a second. Let's take take some of this off here. If I'm looking at the surface area of a sphere, let's say I give you a radius of 5 centimeters, for instance, and I ask you to calculate what the surface area is. If I'm doing that, typically for my class, because we're in integrated math 3, we're getting ready to go into calculus, I'm going to ask you to leave your answer in terms of pi. What does that mean? Well, basically you're going to do all the calculations, but instead of using pi as a pi key or as 3.14, we are going to simply plug in 5. 5 squared is 25, and then 25 times 4 is going to give me 100. So I would say 100 pi, and of course always remember to put your units as square, whatever it happens to be. On different books, assignments, quizzes, tests, the CAS test, it may ask you to do something specific. So there's 3 options basically for this that you can see on the very similar problem. For me, for our free response, I'm going to simply tell you to leave it in terms of pi. You could also be asked to approximate using 3.14 for pi. Or if it doesn't specify either of those, you need to use the pi key, and then it'll say something like round to the nearest hundredth. On the state test, this is very critical that you're paying attention to the directions, because if, let's say, you did this work, but you didn't do the one of these 3 that they want you to do, then the computer is going to automatically mark it as wrong. So you want to make sure you're paying attention to that. I'm not going to go into examples in the video. The resources will be available on class. But if you guys have any questions, reach out to me. Other than that, have a good day.